Hello, everyone. So we have another AMC 1012 problem. So this was number 22 on 10A and 19 on the 12A. So we are given 13 numbers arranged in a row 1 through 13, and our task is to pick them up in numerical increasing order. So this is the condition we are told. So they has to increase as you go, as you pick them up and from left to right. So for example, 1, 2, 3, like I can choose like 1 first, 2 here, 3 here, but even though there is some number in the middle, so it's fine. So we just choose 1, 2, 3 as our first pass. And then 4 and 5, like 4 is right here, 5 right here. So as your second pass. And then the third one, we choose like 6 just alone. And the fourth, 7, 8, 9, and 10 as the fourth, and continue like that. So this is one way to pick them up. But when you do this, that will be 5 passes, right? And the goal is of the 13 factorial arrangement, because there's 13 numbers, you can arrange them 13 factorial ways. How many of them like can we pick these like 13 numbers by taking like those exactly 2 passes? So what does that mean? Like it's just asking us just get those 13 numbers when you actually do this picking like exactly 2 times, not 4 times, not 5 times, not 1 time. So that's the question. So one of the ways we can do, like I can choose like 1, 2, let's say this is 4, 3, like 5, all the way to the 13. So if this is my first list, I can take my like 4 first as my first pick, and then I can take the remaining 1 through 13, except like 4 in this list, we can choose in the second pass. That's one way to make this possible. So I can choose like 12 numbers in my first pass as long as they are aligned like increasing order. And I can choose the last number as my second pass and stuff like that. That's the question. So, but it could be done any number of terms on our first or the second passes, like except the all 13. So for example, like if I have like 1, 2, 3, 4, 5, all the way to like 12 and 13. If I want to pick these into pass, I cannot, because if I choose like 1, 2, but these are also increasing, so I need to take them all together. So which means if these numbers are arranged from 1 to 13 increasing orders, strictly like increasing, there is no way to get these 13 numbers into passes. That will be just one pass, right? So which is why we have to exclude this condition from our cases. So what can we do? Like we can choose one number, but it could be anything in our first pass, and then second could be what is left over. And then I can choose 2 numbers on my first pass, and then I can choose the remaining in my second pass. So meaning that I can choose like 13, choose some numbers. So let's make it general. So K is just the number of like numbers that you are choosing on your first pass. So the K could be 1 all the way to the 12. So and then as soon as you determine the first K numbers, so think about like we are choosing 1 through K. So, and then this is the first pass. In my second pass, I should choose like K plus 1 as my first number, and then I will continue all the way to the 13. So K plus 1 could be 12. If this is 12, so you just have like the 13 is the last number. And if K is 12, that means you choose the first 12 first, and then the 13 as last. But these are the two passes you can have. So, but if I do this, like K could be 1 through 12, right? So, which is why I'm going to use a sum notation, which is, sigma, we name. So this is K, start with 1, and then it will increase all the way to 12. But when we do this, that is also included in this case where all the numbers are increasing from left to right. But we cannot really have this because that will make only 1 pass. We just need 2 passes, which is why any number of terms that we are choosing in our first pass should exclude this condition. Any number of terms that we are taking on the second pass, I mean, like any number of terms that we're choosing in this first pass, let's say 5 or 10 or 1, it should always exclude this cases. So, which is why I'm going to subtract 1 from this case. So again, make sure you really by this before you kind of move on. So you really cannot have this case. And this is basically what we are looking for. What does that look like? So, but since this is negative, I'm gonna kind of take this sum notation separately, so that will be easier to deal with. So we start with k equals 1, and 13 choose k. Okay, and then minus, that is 12, and this is k equals 1. So I'll do this part first, but before we kind of do, let me actually write this first. So the first, this guy is equal to 12 choose 1 plus 12 choose 2, and then 12 choose 3, right? And then it will continue all the way to the 12 choose. Actually, this was 13, so I messed up. So this was 13 choose. So these are all 13. So 13 choose 1, and 13 choose 2, 13 choose 3. And then if you keep adding those all the way to the 13 choose 12, this sum is going to be equal to this guy. And then there is a minus right here, but I'm going to write that separately. So like we have now minus this is like when you choose, like this was actually 1. So when you choose k is 1, the value is 1. K is 2, value is 1. So which means 1 through 12, there is 12 of these. That's the meaning of this notation. So we have just minus 12 from here. But you know, we don't want to find all these sums. Like 13 choose 1 is okay, easy, 13. And then you can even find 13 choose 2. You can find 13 choose 12 because that's the same as 13 choose 1. But for the middle one, I have a lot of work to do. So instead of doing this, we kind of need to remember there was another identity about the combination. So when you have 13 choose 13 in our list plus 13 choose 0, so meaning that you are making a group of like object with 0 element, 1 element, 2 elements, 3 elements, all the way to 13 elements out of 13. So then this is different number of ways that you can combine together. But in terms of those 13 elements, you are either taking or not taking. So which means every time you have 2 options. So meaning that this entire thing right here is equal to, like, since every element has 2 options, either taken or not taken, so 2 options for every element. So you have that 2 options 13 times, which means this thing on overall is equal to 2 to the 13th power. But we are gonna subtract these two because that's not part of our problem. So this is 13 choose, like 0 is 1, 13 choose 13 is also 1, but that's just 2. And then we need to subtract from this. So minus 2. And then minus 12 after. So again, this guy right here is whatever I have right here. Okay. So I mean the red part. So because you know what, for us to get the red part, I just need to add these two to make easy calculation. That's going to be equal to that. So if I subtract 2, which is this is 1, and this is 1, I got the red one as this guy. And then this 12 has to be subtracted anyway. At this point, the rest kind of easier. So we know 2 to the 10 is 1024, which means 2 to the 13 is just 8 times as much because 2 to the 10 times 2 to the third power is 2 to the 13. So if I multiply this by 8, so I will get 8 times 4 is 32, right? That will be 3. 8 times 2, 19. Means 16 plus 3 is 19. So that should be 1, and 8 times 1 is 8. Minus 14, right? So if you subtract 14 from 92, so you will end up getting 78, and that is the choice D. So the question was somehow like challenging, but to be honest, in terms of the work that we do is not really bad, especially when you really understand how we can start with the problem. So that was a bit challenging part. So I hope that was clear. So I'll see you in the next video.